Yes. We are still continuing from where we stopped. You're finding the direction of the vector of that resultant. So the direction will be given as tan theta. So you get tan theta, tan of this will equal to opposite out of adjacent. You ignore that negative sign because already we have shown this direction coming this way. In all your, when they ask you for direction, now you should draw this plane and you show where those units are, and that is it. We just need this angle that vector will be making with the horizontal, full stop. So your theta will become tan inverse of 12 out of 5, and it is what? It is 67.38 degrees. And you conclude, you say that the magnitude of the resultant is 13 units. The magnitude of the resultant is 13 units at an angle of 67.38 degrees to the horizontal. And that is the end of the question. So we go to our number 7 on the menu, which is unity vector. Unity. So you have to know, what does unity vector mean? What is a unity vector? A unity vector is a vector with magnitude 1, or at magnitude 1 is a vector at magnitude 1. Magnitude, you know how to get the magnitude. So when you get the magnitude of a vector and you get 1, that means that is a unity vector. So if V is A in J plus B in A in I plus B in J, remember these tilde symbols should not be put on these letters here. This one is showing the magnitude on the x-axis, magnitude on the y-axis. This one is showing the vector, the unity vector. Unity vector, you remember I told you they are units, like 1 only. Yeah, but now we will need to get a formula for a unity vector. Unity vector of A of this V, unity vector of vector V will be given as, is given by so first of all we write it with that car symbol up. So V, unity vector of V will be just that vector divided by its magnitude. As simple as that. And you can see just this vector you will get after this expression. When you get its magnitude, it will give you 1. Simple as that. So this one from here, you can see that we can express this vector v in terms of its unit vector and the magnitude. If you know the magnitude and the unit vector, you can express any vector in terms of its magnitude and the unit vector. So vector v can be written as unit vector of v times the magnitude. Simple as that. So you should get that. So that is unit vector. I think it is clear enough. We need to move on. Let us first work out some example about unit vector. If you have your vector u as 3 in I minus 4 in j, find the unit vector. So unit vector will be given as that, or vector u will be given as vector u divided by the magnitude of vector u. So unit vector is the same as, this is 3 in I minus 4 in j divided by the magnitude. We said you get the square root of everything, but when they are squared, plus negative 4 squared. And so our unit vector will be 3 in I minus 4 in j out of square root of 9 plus 16 is 25. So this one is out of 5. So our unit vector will be 3 I in I negative 4 in j divided by 5. And this one can be represented as the unit vector u is the same as 1 out of 5 into 3 in I and negative 4 in j. Or you can write it like this, that my unit vector is the same as 3 out of 5 in I and negative 4 out of 5 in j. It's up to you. And this one is a very better answer because it is factorized. Now let us look at we are going to look at the application of this from here, from this unit vector, how to get unit vector. Now this, you can say this one is usually set in the form of this. Say e.g. another example, that a force F of magnitude 20 Newton. Magnitude now is this. The force F is a vector. Acts in the direction 4 in j and negative 3. This is I in j. Find F. Find F. So how do you work out that question? They have given us the direction. So what we are going to do, we are going to get the unit vector of that direction. We are going to get the unit vector of that direction. And the magnitude what we do, find this F. What you do, you first get the unit vector here. This direction is that, so we shall say unit vector of the direction is equal to the direction vector 4 in I, negative 3 in j, out of the square root of 4 squared plus negative 3 squared. And our unit vector in direction will be, this is 16 plus 9, 25. 1 out of 5 into 4 in I and negative 3 in j. That is the unit vector. So we said any vector can be expressed in terms of its unit vector and magnitude. So the magnitude of this force, this is the vector. So any vector can be expressed as its unit vector and magnitude. So this force is the vector, which we can say vector v maybe, and its magnitude is 20. So just needed to get the unit vector of its direction, and then you say this vector F for that force. This one is done. We can now say that that force F can be given as from this. This is now the force F is given as, this one is the unit vector in direction times the magnitude of the force. Magnitude of the force. So the force will be it will be 1 out of 5 into 4 in I and negative 3 in j times 20 Newton. This one goes with this, and you remain with F is equal to 4 into 4 in I minus 3, and this force will be 16 in I minus A and negative 12 in J. That is the force. So they set it like that. That is how it is connected. You connect this idea of unit vector like that. Don't forget that. And so that is unit vector. We have to live with that. This force is measured in what? In newtons. You always have to put the units. If you forget the units, the answer will be wrong. Wrong. I think I can add you another example. Yeah, because the examples are very good and we have our time. You should leave Form 5 when you know this. And even though you're in Form 6, this one is too important for your revision. So another example can be a particle whose speed is 50 meters per second, moves along a line from A to 1 to B 925. Find its velocity vector. Find its velocity vector. So first of all, you are going to find a particle whose speed is 50 meters per second. That 50 meters per second is the magnitude, is the size of the speed per second. The size is 50 meters every second. So now that means you have to generate a unit vector from these two. So the thing is, the particle is moving from A to B. So you can represent that one as A, B, like that. You know AB is equal to OB minus OA. And therefore, AB, this direction. This is direction. So we just deal with direction as far as this thing is concerned. AB will be, our OB is 925. Take away our OA, which is 2, 1. And this direction, which is AB, is going to be 724. So you get the unit vector of this direction vector, and that will be all. So AB will be this vector over it's is 7 in I plus 24 in J divided by square root 7 squared plus 24 squared. See that? And then our velocity vector V will be this AB times the magnitude, the speed. A particle whose speed is 50 meters per second, it is the magnitude of the vector. So 50 and you'll get V. You get V. Can be 14 in J, 14 in J, in I, and plus 48 in J. That is how you go about such a question. This is example number 2. I think that is very okay with unit vector. That is very okay. It is very clear. You are seeing it very clearly. Yes. Now if you have seen it clearly like that, we have to move on. We are going slowly by slowly such that we don't miss out any concept. every concept I want it to be done very well. So I think unit vector is done. We are free to move on to vector multiplication, which is number 8. Vector multiplication. For vector multiplication, okay. Vector multiplication. Yeah, and so vector multiplication is divided. We said we have multiplying by a scalar and by dot product. Let us look at by a scalar. By vector multiplication by a scalar. What does that one mean? That if you have v, vector v is ABC. Then a scalar is a constant which is going to multiply outside here. For example, k. So you can say kv is the same as k into ABC. So this k will multiply everything there, and we have k times vector v will be ak, bk, and c. That is it. That is it. So example, you can let us write this one in v is negative 2, 3, vector v and 2. So one we can find 2 times vector v. Then number 2 we can find negative 2 out of 3 times vector v. So this one is our scalar, which we are calling k. Yeah. So for Roman numeral 1, that will be the answer. It will be 2 into negative 2, 3, 2. So this 2 is going to multiply everything and to be absorbed inside there. That means 2v will equal to negative 4, 6, and 4. Yeah, Roman numeral 2 gives us negative 2 out of 3 v will equal to negative 2 out of 3 into negative 2, 3, 2. See that? And so this one will enter inside there, and you get negative 2 out of 3 v will equal to this time with that you get 4 out of 3. Then this time with this get negative 2. This time with this negative 4 out of 3. Simple. And that is all by a scalar. That's how we multiply by a scalar. Then we can also multiply. We can do what we call dot product. So we can Roman numeral 2 by dot product. Vector multiplication by dot product is 8.2. By dot. So you are going to learn dot product now. What does dot product mean? It means multiplication with addition. As far as we are multiplying two vectors, let us see example. Vector v can be given as a, b, and the vector u is c, d. Now, vector v times vector u is the same as saying vector v dot vector u. So that is dot. So vector v dot vector u is the same as a, b times c, d. So what will happen? This one will multiply, they multiply corresponding entities. So vector v dot vector u will be sc. After multiplying, you add plus b, d. Very simple. Very simple. If it's given as this is, let us say this is category 1. We have category 2, which is, if it's given that vector v is a in I and b in j and u is c in I plus d in j, then vector v dot vector u will equal to a in I plus b in j times c in I plus d in j. So what happens here is that I multiplies I and you get an answer. I times I, since I is a magnitude of 1, you will still get 1. So here you have to learn that I times I is equal to I squared, which is equal to 1 in vectors, but I times j, you get 0. That's why this one is going to multiply with this, and you'll get a c, and that I squared is 1. Then this one multiply with this, you get 0. This one multiply with this, you get 0. This one multiply with this, so plus b what? bd. Simple as that. That is the answer. So don't forget this. This one is a very, very, very important concept. Let's look at some example. You can say, note this question down. Find the scalar product of the following. 1, I want us to move slowly such that everybody will understand. It's 2I plus j and I minus 3j. Find the scalar product of this. This one means you will say 2 1 dot 1 negative 3, and this one it will give you 2 plus negative 3, and the answer will be negative 1. Simple. Number 2. I can say find the scalar product of 3I and negative 2 in I plus j. This one means if I'm multiplying this one to be 3, 0. Because this one is having j, so I put this one to 2 dimension. Dot negative 2 and 1. So I get only the answer is negative 6. Negative 6 plus 0. The answer is negative 6. See that? I can also say that Roman numeral 3 can also tell you find the scalar product of 4 in I plus 2 in j plus 5 in k and negative 6 in j plus 2 in k. So here the answer will be say 4, 2 and 5. This one is having all the 3, but this one is not having I. Not having I, therefore we have 0, then negative 6, then 2. So dot. When you dot this, you get 0 plus negative 12 plus 10, and the answer will be negative 2. To be negative 2. So if you want to put something here, you just say let it be the same as A. So you say A equals, you get the answer. It's like that. Therefore, that is enough. We go, vector multiplication is done. Angle between vectors, number 9. Number 9. Angle between. Now we have 12 things. Angle between. And we leave this topic. Angle between vectors. So, say if theta is the angle between vectors A and B, and it means I'm talking of this. If theta is an angle between vector A and vector B, this is acute angle. Then using dot product, you will say A dot B will be the same as A magnitude times B magnitude, then cos of the angle between them. So that angle between vector can be given like this by dotting the vectors. If they have given you vectors, they want the angle between the vectors, you dot them, and you get the angle. And you get the angle. If theta is the angle between vectors A and B, they have drawn it like this. This angle between vector A and vector B is given by this expression. Very simple. Let me first rush to number 10, perpendicular vectors. This one is very simple. You can even hear the word. The way the word is simple is how it is simple. Perpendicular. Yeah. For perpendicular vectors, it means when you dot them, if this is vector A and this is vector B, if you say A time you dot that one, you get A magnitude times B, then cos of 90 degrees. But cos of 90 degrees is 0. Therefore, you'll end up saying A dot B is all of it, you get 0. So for perpendicular vectors, their dot product gives 0. And that is something very important to know. I think everything is clear. Yeah, if you follow this from the beginning to the end, you never suffer. You never suffer in math. This is the end of your suffering. So let me pose a question here. I'm posing a question here. There is this question which says, given vectors of magnitude and the angle between being theta, find A plus B magnitude. So for that you'll say let A plus B only, A plus B, let it be R. So you remember we have this A plus B from Pascal's triangle squared will be given as A squared plus 2AB plus B squared, which is the same as A squared plus B squared plus 2AB. You know very well that magnitude means square root of everything squared. That means A plus B is the same as R squared, and I get its what? Square root. See? The same as that. But my R alone is A plus B. That means R squared. This implies that R squared the same as A plus B squared. And this one will give me my expansion there, which is A. This is A squared plus B squared plus 2AB. But when I multiply, you know, when I multiply, I get a constant. So this will be constants now, plus b squared plus 2ab. AB also gives a constant. Now, you need to know something small here. If you have a vector a and you get it, see, modulus. You have vector a and you take its modulus, then it means this modulus means the same as a times a. Then you take what? Square root. But a times a, you get a constant. Therefore, it's the same as the constant a squared. Under square root. Then that means a, when I remove this square root symbol, I'll square this, will be equal to a squared. Therefore, I'm going to substitute. Where there is a squared, I'll put this one there. I think we have followed very well. So, for that, from up here, I've seen that a squared is the same as modulus of a vector a and the square that. Therefore, I will say that but a squared is the same as modulus of a vector a squared, and b squared is the same as modulus of b squared. Therefore, I will say and I know that vector a dot vector b gives me vector a modulus times vector b cos theta. See that? That means modulus of a plus b is the same as the square root of a squared modulus plus b squared plus 2 modulus of a modulus of b cos theta. See that? Where is this one coming from? Remember this one. A plus b is the same as square root of a plus b is r. So the modulus means I square r and I get the square. But r is this, so r is this. All of that. See this and this one. That is my r. Now my a squared is the same as this one squared. See that? And so my r squared is all this thing here. Therefore, a plus b magnitude is the same as square root of r squared. But you know that magnitude of this one is equal to a squared. Therefore, if a squared is equal to this, means even a is the same as the magnitude if you remove the squares up according to indices. Therefore, my a will be magnitude of a, which is here, and my b will be magnitude of that, which is there, which is that. And I just fill in, and that is the answer for such a question. Then I can also have numero 2. A minus b. Find that. This implies just say let a minus b equal to what? Let us say p. That means if you are saying p magnitude a minus b magnitude is the same as p squared under square root. Now let us work out p squared. This one we shall get from the expansion a minus b. Say from a minus b squared is the same as a squared plus b squared minus 2ab. That means that also a minus vector b equal to vector a squared vector b squared. That now you said vector a minus b is the same as p, so this one is the same as p squared, same as a squared plus b minus 2ab. So what we are left with is to substitute. Yes, we want, what we want is different. We want p squared under square root, which is the same as the a minus b magnitude. So a minus b magnitude will be the same as square root of this one, which is a squared plus b squared minus 2ab. But we can substitute these squares for modulus. If you have, as I told you, if you have magnitude of a, it is given as, if you have vector a and you want to get the magnitude, you said it is the same as a times a, then after you get the square root, and this one will be the same as square root of a constant a squared. So to remove this square root symbol, you get a squared is equal to a squared. Therefore, a is equal magnitude of a if you remove the squares. This is what I'm talking about. So you get it clearly. So we are going to substitute where there is a squared, we shall put this one. This one can remain as vector a squared, but you know it will turn to